Okay, so starting here, what did you write down already? You reviewed the definition for theorem. A theorem is a statement that has been proven as true, kind of like a theory that you see in science, but math related. There are three types of proofs. So yesterday I introduced you to a 2-column proof. We'll continue using that. It's like the most common form of a proof, but there's also other formats such as a paragraph or a flow proof that'll come up here and there, just so you're aware. When you're doing a proof, we have the 2 columns, like you saw yesterday, statements and reasons. And then the reasons can be either postulates, properties, definitions, or theorems. Yesterday, we pretty much just focused on properties, like properties of equality. But today we're going to bring in some of the other ones. So, yeah. So these are the postulates that can come up today in the proofs. The first one is segment addition postulate. You've actually seen this before, so it's not new. We're just like seeing it in a different format. So segment addition postulate, what that means is this part of the segment plus this part of the segment added together equals the length of the whole thing, like this. So that is segment addition postulate, and just kind of make sense of the name so that way you can recognize it. So segment, it's a line segment. We're adding parts of the line segment together to get the whole thing. And then in equation form, it would look like this. AB plus the length of BC equals the length of the whole thing, which is AC. So this plus this equals the whole thing. Okay, then the next one is a few definitions that can come up in the proofs today. Again, you've seen these concepts, which is cool. It's just like a review. So the first one, definition of congruence. If the length of AB is equal to the length of BC, then you can say that segment AB is congruent to segment BC. So if they're equal in length, then those segments are congruent. And also, if AB is congruent to BC, then the length of AB equals BC. And again, that is definition of congruent. This definition of congruence. And we'll have definition of midpoint. Okay, then next is definition of midpoint. So what this means is that if you have a segment like segment AB, and you're told that point M is the midpoint, so you're told, hey, point M is the midpoint, then you can say that segment AM is congruent to MB. They're the same length, because if this is a middle, then this part of the segment would be the same length over here. Then AM is equal to the length of MB. Okay, then next, these three are similar to what we saw yesterday: reflexive property of congruence, symmetric property of congruence, and transitive property of congruence. Okay, so reflexive property is something's equal to itself. So segment AB is congruent to segment AB. It's just equal to itself. Why do we need to define that? You'll see in some of the examples why we define that, but not today. And then symmetric property of congruence, that's like if AB is congruent to CD, then you can say that CD is congruent to AB. You can just change the order around the equal sign, and it's still equal, and that's symmetric property of congruence. Do you have your phone today to put it up? Okay, and then transitive property, if we went over this, but it's essentially if A is congruent to B, and then B is congruent to C, then we can say that A is congruent to C. So the example I gave yesterday with height, it was like if, I don't remember which people did I use? I don't even remember. Zoe and then Calvin and me. Okay. Oh, she isn't here today. Okay. So the visual example for this would be like if Calvin is the same height as Jillian, and then Jillian is the same height as Zoe, then we can say that Calvin and Zoe are the same height, and that's transitive property. And then down here, the properties of equality. We went over all of these yesterday, and they can come up today, and you'll see how they come up. But yes, all these are fair game. Okay, so then we are going to practice integrating these into different situations or identifying them in different situations, just like we did yesterday. So for this practice, it gives us some examples, and then we just identify the property that's taking place. So here it says if PQ is equal to PQ, then PQ is congruent to PQ. So if they're equal, then they're congruent. That is definition of congruence. So I'm going to abbreviate a little bit, but also try to make sure that we're going over the concept too, so you're writing it out so you can learn the words too. So just having a balance of both. Then number 2, it says if K is between JL, then JK plus KL is JL. So if K is between J and L, then JK plus KL is the whole thing. That's segment addition postulate. Segment addition postulate. Okay, the next example, EF is congruent to EF itself. Based on our examples, that is reflexive property of congruence. So reflexive property. And number 4, it says RS equals TU, then RS plus XY equals TU plus XY. So they go from this to this. They're adding XY to both sides. So that is addition property of equality. And the next one, AB equals DE, then D equals AB. They just changed the order there. That is this one here, which is symmetric. The symmetric property. Then for number 6, it says Y is the midpoint of XZ. Then XY is equal in length to YZ. Well, since Y is the midpoint, yes, this will be the same length as this. That is definition of midpoint. Then the next example, FG is congruent to HI is congruent to JK, then FG is congruent to JK. So that is the Calvin's the same height as Jillian's the same height as Zoe, then Calvin and Zoe are the same height. That is transitive property. Okay, the next one, number 8, AB plus CD equals EF plus CD, then AB equals EF. So to go from this to this, they subtracted CD from both sides. So that would be subtraction property. Okay, then number 9, EQ plus RS equals TV. RS equals WX, then this. Okay, so what they did here, since RS equals WX, they took WX and like plugged it into this equation here for RS, to get this. So they used substitution. So since RS equals WX, they just replaced RS with WX to get this equation. So that would be substitution. Then number 10, LP equals PN. LPN are collinear, meaning they fall in a straight line, and P is a midpoint of LN. So if P is a midpoint of LN, LP equals PN, then P must be the midpoint. So that is definition of midpoint. And here, UV is congruent to UV, then UV is equal to UV. To go from congruent to equal in length, that's definition of congruence. And then here, CD plus DE equals CE, and then they have CD equals CE minus DE. To go from this to this, they subtracted DE from both sides. And so that would be subtraction property. Okay, so what we're going to do from here is we're essentially doing this same thing. We're just looking at the situation and identifying a property or definition or something that would explain that situation. And that's what we're going to be doing in the proofs here. So here we have a 2-column proof. The left column is the statements and the right column is always the reasons. It will always give you a given. So this given goes in the first line. So given is E is a midpoint of DF. E is a midpoint of DF, and we write given here. Also on the right is an answer bank. When you see this on testing or anything, you're not having to come up with reasons off the top of your head. There's always an answer bank, and it's usually like drag and drop. So once we plug something in this case, we're going to cross it off because it's only one choice per thing. Okay, so given that E is a midpoint of DF, we're trying to prove that 2 DEs is equal to the whole thing, and it walks us through the steps, which is nice, so we're just identifying reasons. So here it says E is a midpoint of DF, cool. Then they say DE is equal to EF. Well, the reason why those are equal is because that's the midpoint. So the reason here is definition of midpoint. And then we can cross that off. Okay, the next one, I'm just looking at what's happening and then identifying a property. So they go from this to this. They're adding DE to equals EF. They added DE here and a DE on this side. So they added the same thing to both sides. That's addition property. Okay, and then to go from this to this, it looks like they combined like terms, like DE plus DE is 2DE, and then they left this the same. So I'm looking for like combined like terms or something like that. That's not there, but they do have simplify, so I think that's the best answer, simplify. Okay. Then for number 5, to go from this to this, let's see. I don't see a direct correlation, but when I look at the picture, DE plus EF equals DF, the whole thing. That's segment addition postulate. So segment addition postulate. And then the last step is this. I only have one thing left, but I want to make sense of it. This here, DE plus EF, matches DE plus EF. So then I can put this equal to this, which is exactly what they did. They put 2D equal to DF. So that would be transitive. Okay, then flip to the next page, and we'll just keep practicing. Okay. So again, same process, just I'm going to keep practicing. The given always goes in the first line. So it looks like they already filled that in, and then given would be right here. And then just looking at what's going on, they're saying KL is congruent to LN and LM is congruent to LN, and they want to prove that L is the midpoint of this segment. Okay, so they have these segments are congruent, then they said they're equal, so that's definition of congruence. So already I got 50% of the problem right. Then they're saying KL is equal to LM. Well, here's LN and LN, same thing. So they can put KL equal to LM because they're both equal to LN, so that is transitive property. And then if KL is equal to LM, then definition of congruence, definition of midpoint would say that L is a midpoint. Definition of midpoint. Since KL is equal to LM, then L must be the midpoint. Definition of midpoint. Then number 3, same thing. The first statement is the given. Cool. PQ is congruent to TQ, and UQ is congruent to QS. I'm trying to prove that PS, this whole thing, is congruent to TU. Okay, we have the given, the congruent statement, then they say they're equal. That's definition of congruence. Crossing things off too. Okay, then the next statement, PQ plus QS equals PS. PQ plus QS equals PS, that is segment addition for both of those. So segment addition postulate. Cross it off. Okay, so the next part, so they have this statement right here, and they know that PQ is equal to TQ, so they take TQ and replace PQ with it to get this. So that is substitution. Then next, here, TQ plus QS is TU. Okay, so if QU equal to QS, and then they just take this and they plug it, they replace this. So substitution again. And then you have matching parts right here, these match. So therefore, they can put these two equal. And so that would be transitive or substitution. They have transitive there, transitive. And then go from equal to congruent is definition of congruence. This one here. Statement, remember, given always goes here, so we can get that right away. K is a midpoint of JL, M is a midpoint of LN, and then they say JK is equal to MN. Okay, well, if K is a midpoint, then this is equal to this, and M is a midpoint, then this is equal to this. That is definition of midpoint here. The next statement, JK equals MN, is actually part of the given. So sometimes that does happen where there's a given later as a thing too. And then, let's see, if JK equals MN, they just take this and they substitute it here for JK. So they're using substitution. Then from there, LM equals KL. Well, we have MN and MN, those are matching, so they put KL equal to LM. So that would be transitive. Do they have transitive here? Yeah, transitive. And then KL equals LM. They went from LM equals KL to this. They just switched the order, so that's symmetric property. And then definition of congruence equal to congruent. There's one more I want to do, and then we can start the homework. On this side, it's essentially they continue. But the bottom one on this side, it has blanks on both sides, and that's more or less how you'll see the homework. So on the homework, let's see, grabbing my example here too. Okay, so on the homework, it'll be drag and drop. So you'll have like an answer bank and everything, and you're just dragging and dropping. So, and there'll be blanks on both sides. So that's why I want to practice this one with you. Here for the given, it says E is the midpoint of AC. So then we can say like AE is going to be equal to EC. That'll probably be one of the things we fill in. And it also says DE is equal to EC. Okay. And we're trying to prove that DE is congruent to AE. Okay, so E is the midpoint of AC. That is given, so we can fill that in right away. There's no bank here. I don't know why there isn't a bank, but on the homework there'll be banks. And then definition of midpoint, well, if E is the midpoint of AC, then AE equals EC. AE equals EC. And then the second part of the given is DE equals EC. So both of these are equal to EC, so therefore we can put AE equal to DE, and that is transitive property. And then the next reason is definition of congruent. So I think they want me to say, okay, AE is congruent to DE. They're equal, then they're congruent. And then they just switch the order. DE is congruent to AE, and that is symmetric property. So all you're doing is looking at the situation and identifying the property or definition. So on the homework, there's only 4 problems, and then you get partial credit every space you fill in. So try it out, take your time, let me know as you need help. And yeah, you can grab a laptop and get started.